Okay, everyone. So we continue with the with true sensor. Okay, we continue study.
Welcome. The purpose of this module is to introduce spectrum of sensors used to implement intelligent machining.
Intelligent machine.
This module will also discuss the basics of signal processing and analysis techniques that has brought intelligent machining paradigm closer to industrial realization. At the end of this module, you will be able to identify at least three types of
Three
sensors
time
used in
sensor.
monitoring manufacturing processes, describe the basics of signal processing, and define
Different
machine
machine
learning.
learning.
In this lesson, we are going to focus on different types of sensors that can be used in industry. Upon completion of this lesson, you will be able to explain what different types of data sensors could be used in the monitoring of manufacturing processes. Sensor is a device that detects or measures a physical property and records, indicates, or otherwise responds to it. Few examples of sensors are acoustic sensors, thermal sensors, magnetic sensors, and optical sensors.
Optical
Acoustic
sensor.
sensors convert sound into an electrical signal.
Acoustic sensor.
Example of this class of sensors are microphones.
Microphone.
In microphone, sound is first converted to mechanical motion by means of a diaphragm, the motion of which is then converted into an electrical signal. Microphones are extensively used in telephone, hearing aids, and concert halls. In manufacturing applications, acoustic sensors like microphones could be used to monitor the machine performance. The recording from microphones could be used to detect tool wear. Thermal sensors are used for measuring temperature or difference in temperature. An example of this class of sensor is thermometer. Thermometers can be used to measure temperature or temperature difference, and they are used widely in industrial and medical applications. In industry, the temperature of a cutting tool is continuously monitored by thermal sensors like thermocouples. This helps to regulate coolant flow. Magnetic sensors are used for sensing magnetic field. Generally, they use electric voltage for detecting magnetic field. An example of this category of sensor is microelectromechanical or MEMS magnetic field sensors. It is a small-scale MEMS device for detecting and measuring magnetic fields. These sensors can also be used for sensing corrosion on a part. Optical sensors are used for sensing light. Photodetector is an example of optical sensor. A photodetector converts light signals that hit the junction into voltage or current, used extensively in TV manufacturing. In manufacturing applications, optical sensors are generally used for inspecting the quality of the finished product.
Sensors in machining centers are helpful, so we want to have our machines know where the parts are in the machine. So they'll have to probe a part, they'll have to touch off a part, they'll have to know where that part is in space. Sometimes they'll be touching off on fixtures or the part themselves to know where that is, so those sensors are important. Another place that sensors are used is sensors are used to detect broken tools. Before a machine program runs, we want to make sure that we're not going to be making scrap parts when the machine may be making hundreds or even thousands of parts. So that sensor will check to make sure that the tool is present and not broken before the machine will even run. That sensor communicates back to the machine and kind of qualifies the run for us.
Okay, we see this. Touch sensor surfaces. Thermal. In circle control experiment. Power control. Yes. Okay. At least three types of sensors used to monitoring manufacturing processes. Headline principle magnetic sensor. Okay. Three types. We have one here. Magnetic sensor. We have accounting sensor. Accounting. Accounting sensor. And we have what? What more? Check again. Yeah, thermal sensor. Optical thermal sensor. Principal magnetic sensor. Magnetic sensors are used for sensing magnetic field. They use electric voltage for detecting magnetic field. photodetector magnetic sensor yield electric voltage for detecting magnetic field. Magnetic sensor yield voltage to yield electric voltage to detect magnetic field. Okay, to the magnetic field. For not true. For detecting magnetic field. Okay, we continue. Signal processing.
Our topic for this lesson is signal processing. Let's consider the question, why signal processing?
Why signal processing?
Before understanding the concept of signal processing, let's first try to understand the meaning of the term signal in the intelligent machining domain. Signals describe how some physical quantity, such as temperature, sound, etc., varies over time and or space. For example, consider network of your smartphone. The phone has a set of bars displayed on the screen to indicate how strong your network connection is at a given time and place. If 5 bars are full, your network connection is strong. When it drops to 2 bars, you should expect a weaker connection. Here, the signal we reference describes the strength of the phone network. Signal can be represented in various forms such as bars, waves, and curves. As discussed in the previous lesson, different types of sensors can be used to monitor the wear of cutting tool and the temperature of machining tool tip or workpiece. Sensors collect the information in different forms such as sound and light, etc. This information may not be in the form we understand or may contain noise. For example, a sensor may be monitoring sound from a machining center. The overall sound recorded by the microphone sensors may contain voices of operators or sound by nearby machines in a manufacturing shop. The additional source of noise leads to errors in signals. Consequently, the initial signal, that is the sound, should be cleaned up to remove the noise. Once the noise is removed from the original recorded signal, the cleaned noise-free signal can be used for pattern checking by comparing the current noise-free signals with previous recorded signal datasets. Thus, signal processing includes all those activities that needs to take place to convert the signal collected at the source into information that could be used to make decisions. This could include cleaning up of the initially gathered signal to remove noise and analyzing the data to generate actionable information.
Okay. So, what is signal processing? What is signal analyzing? Origin lab signal processing. Okay. Signal processing is practical guide for engineering scientists. Okay. Two question. Open this one again. Close this one. Explain the concept of signal processing. Signal processing. Signal yang mean a physical quantity sensor. The sensor microphone. Sensor sound from microphone sensor contain volume correction. So noise. On activity that need to take place to convert the signal collected and the truth into information that could be used to make decision. Then after initial gather signal to remove noise, analyzing the data to generate actionable information. So signal processing E on the activity to convert the signal collected and show into information. Convert signal collected and the source into information that can be used to make decision. That's it. On the data, the conversational collected and the source into information that could be used to make decision. Okay. Define how physical quantity vary over time and space. Define signal describe how okay transforming data into information.
This lesson is a preface to the following lesson on machine learning and artificial intelligence in sensing. In this current lesson, we will be introduced to factors driving the need for machine learning to transform large sets of data into information that can be used to make smarter decisions. In this lesson, we will learn the meaning of terms, features, and how features can help convert raw data into prediction using machine learning. Using a few day-to-day examples, students will learn how all our lives are being touched by fusion of several exciting and emerging fields of technologies such as machine learning, artificial intelligence, and big data. Let's consider the question, why machine learning? As we discussed in the previous module, that is module 1, we need three main components to enable intelligent manufacturing framework. First, sensors to collect data. Second, a data acquisition and management system to process and store data. And third, machine learning and knowledge discovery component to process the stored data. We spoke about components number 1 and component number 2, which is sensors collecting data and signal processing in the previous lessons. Now, let's discuss how the output of signal processing can be used by the machine learning and knowledge discovery component to make decisions. In this context, we will introduce the concept of machine learning. To understand the concept of machine learning, let's consider an example. You may have used Netflix to watch your favorite movie. You log in, search for a movie title, then select a movie, and you watch it halfway or in full. Then you sign out and go about your daily life. Once you log back again into Netflix system, have you noticed that the system gives you a list of recommended movies in a similar genre to the one you have watched previously? How does that occur? The system uses data from our previous system uses and learns about our likes and dislikes and makes predictions based on our past uses of Netflix. This is an example of machine learning working in our daily lives. In the Netflix example, some features used to make predictions are the age of the user, genre of the movie, and movie actors. Features are salient way to abstract and represent data that are useful to make predictions. There are several other examples of machine learning in action in our daily lives. For example, social networking profile recommendations features of LinkedIn and Facebook uses machine learning. The online shopping recommendations in Amazon and eBay are enabled by machine learning. The machine learning is also pivotal in implementation of automated office assistants such as Apple's Siri and Microsoft's Cortana. In general terms, we can explain the conceptual working model of machine learning as follows. Machine learning focuses on the development of computational models that can teach themselves to learn patterns or models from existing data and utilize the learned model when exposed to new data. In the advanced analysis course, we spoke about big data, high volume of data of wide variety being generated at high velocity, the 3 V's of big data. Machine learning systems search through big data to learn patterns in the data and use these patterns to make predictions or recommendations in light of new data. For example, recommending movie genres a user may like based on patterns learned from the past users is the use of machine learning.
Okay. We got something? Yes. Lesson 3, transform data into information. 4 important steps. Converting data into information. How Netflix analyze your select movie. Okay, how the data you in Amazon recommendation. Okay. Okay, video this one, and we start. Arrange the following step in order so that intelligent machine work efficiently. Efficiently. Signal processing data. So we copy first, then we arrange it later. What the hell? Okay. We can do like this. Okay, sensor collect data. This one is first one. And then signal processing convert decision into improvement action to change system behavior. Make decision based on the output from signal processing, convert decision into improvement. Okay. Give at least 2 sample machine learning that we use in our daily life. First one is Amazon recommendation and Netflix recommendation. We can use social networking provide recommendation feature. Social networking recommendation feature. Okay, the second one, Amazon. Movie recommendation. Yes, we can put movie recommendation feature. Okay. Practical use of machine learning.
Welcome to lesson 4. Building on the concepts outlined in the lesson 3 on machine learning, this lesson will delve into the uses of machine learning in sensing. We will learn how machine learning is creating disruptive innovations in the smart manufacturing domain, thereby enabling extremely useful applications in digital manufacturing and design domain, like vision systems for automated high-speed quality control and product classification using the digital thread. Pay attention to the following example that illustrates the uses of machine learning in industrial settings.
Sensors in machining centers are helpful, so we want to have our machines know where the parts are in the machine. So they'll have to probe a part, they'll have to touch off a part, they'll have to know where that part is in space. Sometimes they'll be touching off on fixtures or the part themselves to know where that is, so those sensors are important. Another place that sensors are used to detect broken tools. Before a machine program runs, we want to make sure that we're not going to be making scrap parts when the machine may be making hundreds or even thousands of parts, so that the sensor will check to make sure that the tool is present and not broken before the machine will even run. That sensor communicates back to the machine and kind of qualifies the run for us.
In addition to intelligent machine sensing, machine learning can be used to enable various advanced manufacturing enterprise functions. For example, in the optimization of the overall supply chain. Over 70% of Many manufacturing companies' products are sourced from the suppliers. Using machine learning, suppliers and buyers collaborate effectively to reduce stockouts and meet customer delivery dates. In predictive maintenance and repair applications, machine learning can be used to predict the servicing and repair times of machines based on usage pattern of the machine. Machine learning can also be used to increase production yields. Aerospace, defense, and other high-tech manufacturers today are using machine learning techniques to increase production capacity, to do quality control and forecasting.
Okay. Forecasting. Okay, close this one, we open this one. Okay, state at least one advantage of machine learning in advanced maneuvering and free. Explain how machine learning in advanced manufacturing can optimize supply chain. One advantage of machine learning. Okay. Detect broken tool. One event. Detect now in machine learning. Not event here. Optimization of the overall supply chain here. Optimization of overall the overall supply chain, the overall supply chain. Okay, explain how. Over 7% of manufacturing products are from supply. Using machine learning, supply and buyer collaborate efficiently to reduce here how innovation application machine learning usually certainty that machine learning can be used to improve product yield. Yeah, this one. Supplier and buyer collaborate effectively to reduce using machine learning. Supplier and buyer collaborate efficiently to reduce stock out and meet customer delivery date. To reduce stock out and meet the delay and meet customer delivery date. Stock out and meet customer delivery date and meet customer delivery date. Meet customer delivery date. That's it. Okay. Evolution. Let's talk robotics. After watching the following video, what skill and job routine are necessary to open the robot? Okay, we will do it later. We will do this one first. Okay. Which of following sensor work on principle of sensing like optical, true or false? Signal can be expressed only as wave. Signal can be expressed only as wave. No, false. True or false? Sensor collect the information only from sound. True or false? Amazon is an example of machine learning way. System should to big data to look for pattern and use the pattern to make prediction. Should to big data machine learning. Should to machine learning with the following is not related. Machine learning in advanced manufacturing, auto-free, optimize supply chain yes degree in repair performance, in reroute yelled by optimization of team machine supply customer requirement degree in repair performance. Machine learning technical can be used to optimize staff but not supply. Optimize staff but not supplier for all. Technical can be used to find co-express relation. Machine learning by DOE technical we can avoid weightage optimization. What is DOE technique? DOE data optimization something mean design of experiment can be avoid way design of experiment to a device that detect unusual physics record physical property and record indicate other function measure physical sensor. Okay, 100. Yes, that's it. Machine learning apply machine learning. Okay, last one we will see the video FANUC robotic intelligent machine. What's Q?
Hi, I'm Joe Svengros, Director of Marketing at Fanuc Robotics here at the IMX show. I'd like to introduce you to some of our latest technology here at the show. At our Intelligent Machining Center, we have 3 key pieces of new technology and existing technology that we're demonstrating here at the show. We have our pictureless vision, IR vision, that we're actually locating the parts. They're coming down. The robot has a display. We're actually locating the parts, communicates back with the robot. The robot knows to pick up the part and actually place them into a lathe demonstration that we have here at the show. The second part of our demonstration includes our latest technology with our force sensing device. Our force sensing device is actually being used for a gauging station here where we're checking good parts and bad parts on the outside diameters of these components that are being manufactured. The gauging process will go to an accuracy of plus or minus 0.04 millimeters. This force sensing device not only can be used for gauging, but it can be used for deburring, force loading, inserting, and matching applications. So there's a lot of different applications not only here at this component. The third key component is our machine tool connect software. This new software communication connects the robot directly with the CNC machine. So we are able to do remote operations of the robot from the CNC machine. We're able to display info on the CNC screens for both alarms, I/O, and programs, as well as we're able to display the CNC information on the teach pendant. So, give a demonstration here of, this is a screenshot of what is actually coming up on the robot teach pendant. As you can see, as the communication is going with the CNC, we're actually able to see the information displayed. Here on the teach pendant, we are able to see the communications with the CNC equipment, so that we now have, with the new machine tool connect software, we'll be able to communicate back and forth with the CNC with the robotic application. With the force sensing device, we are able to measure and check good parts and bad parts based on the tolerance that's being set. As this display shows on the teach pendant, we have several parts that are coming up with green that meet the tolerance that is expected, and when a part is out of tolerance, we are displaying that in red. We were able to communicate that information back to the CNC machine to minimize poor quality products and increase productivity.
Okay. They asked us, after watching the video, what skill or job do you think to operate the robot? What skill? PLC programming. PLC programming. What skill? Automation. That's it. Operate, yes, operate. Maybe a machine learning. Skill intelligence. Okay. Sensor. Data. No, this one okay. I think it's enough. Visual automation. Yes. Programming skill, digital knowledge, mechanical skill, communication skill, something like this. Okay. That's it. Okay. So we finish with number 2 and with number 4. Okay, basic programmable logic controller. That's it.